Never know.
Keep talking. Keep talking.
Keep talking.
Yeah, I'm not started yet.
He's prepping.
You're prepping?
Inside of it, and we're seeing better.
Then you're gonna have my pointless conversation on like the video. I mean, literally everything I say is
Yeah, but you can
pointless.
edit that out.
I'll switch over.
But he won't. Believe me, nothing is ever edited out. Yes, I have watched the video. Believe me, I know the stupid things that end up on my mouth. Some I regret, some I don't. How do you like the weather?
Me?
Yeah.
Good. Why are you asking?
Because it's getting nicer out. I'm tired of the snow.
It's too hot.
Yeah.
It is. There is still wind. It is still chilly. You go into a. Just walk in the shade. Because it's
I walk down here like this and I'm still sweating.
Yeah, you know what? I'm totally. I think I'm a little cold today. I didn't wear enough layers.
Warm up enough for the snow to melt. For me to run outside.
That's nearly there. Nearly there. It really is nearly there.
You see this, right? Have you seen this?
Oh my gosh, so I'm still like of the opinion that maybe we should run the best I've ever seen.
I know, right? It's fantastic. It's so sad. I don't think I have the picture anymore, but like.
So we'll start. And Sarah, any more comments? No? Okay. So this is the formula, and this is the Mohr circle, and this is the given information. And here, let me not to draw the other two sides, basically they are symmetric. And for the Mohr circle, the first one, we have to determine the center. The center basically located on the horizontal axis and with at least at these locations here. So let me label the point here. The radius is equal to this number, sigma x y squared plus tau x y squared. Okay. So with this one, basically we can draw the circle, and allow me not to draw the circle by just using one stick, and which indicating the diameters. Here, that is, let me using this one. Okay, so on your handouts, this is point E, and let me say this is point A. So A is form a diameter. Basically, this is our center here. From center, the CE or CA basically equal to R. The radius equal to this one. So if we use this as a center using this as radius, we can draw a circle. Okay, so that is a circle here. And now, using this approach, I'm going to simultaneously give you a review how to label the Mohr circles, how to label the points on the Mohr circles. And let me use working on the two sides, okay, and probably you can using 2 pages. So one page is to document this one, or you simply follow the handout. The other page is one example. For example, here we're working on define the coordinate systems first. If you wish, you can define your coordinate system always using your right-hand rule. If you wish, you can define as xy like this, or you can define your coordinate system like xy like this, whatever. Okay. This one is called the x-plane, so that means for this case, x-plane is here. And y-plane for this case is top, facing in the y direction, and y-plane is here, y-plane is here. Okay, good. So with this case, then here let me give certain numbers. For example, this is 10, and this is 4, and this is 3, 4. So this is 4, okay. So using this example, then we can demonstrate how to make the circles here. So for this one, first one we calculate the center here is 10 plus 4 equal to 7. And radius equal to 10 minus 4 divided by 2 squared plus 4 squared, basically this equal to 5. So from here we build up the coordinate systems, the normal stress and strain stress. The center is at 7 and this is 5. Okay, roughly like this one, sorry.
I think that's the worst circle I've ever seen drawn so
Wow.
far. No, his circles are always perfect. It's like. Wait, no, not yet.
My goodness.
Wow, Sarah.
Jeez.
Okay. So this is the center from here to here. This is 7. And the radius equal to 5. Okay, so basically I don't need to label. And now the first step is to label the status. To label the status of the given information onto the Mohr circle. And here we're going to use 2 points on the Mohr circle to represent the status of the given one here. The first one is we label the x point. The x point representing the distribution of the stress components on the x plane. And this one is using the normal stress component and the strain stress component. Okay, that is the sequence. Basically here is we have a normal stress which is 10. Again, side convention for tensile positive. For shearing, we filled up the magnitude 4 first. And here I like to edit up notation or directions of the shearing. And here you can see the shearing for here has a tendency to rotate this plane to how to say the shearing 4 has a tendency to rotate this stress element about the center by counterclockwise. Okay, so basically here we give the sense of the rotation 4 like this. And here in this way, the Mohr circle to make everything consistent, here this is the rotation sense, and the top quadrants are in that sense. The lower quadrant is in this sense. So under this situation, we can uniquely locate the point. So this is 7 and 8, 9, 10 about here. So then 10 is here, and there's a 2 possibility here and here for x where the bottom one, because the 4 is following this direction. So this is our x point. Okay, so here the label 4 and 10 and 4. This point on the Mohr circle representing is the status on x plane. And we can work on the y plane. The y plane has the normal stress 4 and shear stress. On the y plane, the shear stress has the tendency to rotate this cube about the center clockwise. So this is a symbol here. So this is 7, 4 should be around here. So again, the y should be here. And if your drawing is perfect, is correctly, then connecting x to y will be 1 diameter. So that means they must pass the center. If you're connecting your x, y didn't pass the center, then you got the wrong locations. Okay, so that's the way. And for example, A and E representing a certain direction. For example, A actually is our x point. Okay, and here E representing is our y point. So here for using that symbols, let me correctly build up this location here. This is sigma x. And this is tau xy. And for this here, so this is tau xy, sigma y. And here is tau xy. the center from here to here is sigma x plus sigma y divided by 2. Okay, and then here let me draw a line which is perpendicular to the neutral to the horizontal axis from the xy point. Okay, so that means the distance here. Basically, this distance is the difference between this and this. If you do this calculation quickly, you can find that is sigma x minus sigma y divided by 2. And here, for this demonstration, I assume this is larger, this is smaller. Okay. So the same thing, the distance here, the same thing here. So that is sigma x minus sigma y divided by 2. So that is the 2 points is on the Mohr circles. And now we're going to rotate. And